Hello and good day everyone, my name is Ron and let us answer some linear regression problems. Use the following data file found in this link, which is the Excel I will show you later. The data is all about the gas turbine emission of CO, carbon monoxide, and nitrous oxides. Using the Regression Learner app in MATLAB, determine if the variables have correlation or not. So for those students with student numbers ending in an even number set A, which is myself, determine the correlation between carbon monoxide and the rest of the variables except NOx. And use all, and another special condition for set A is that we need to use all three models in performing regression training. Then for both set A and B, use the default validation method. So what do I need to determine? So I need to determine one, the R-squared values and the root mean squared values, and two, I need to explain what does the R-squared value tells us. And three, what does the response plot tells us? How about the predicted versus actual plot, and what can I say about the residual plot? And four, I need to find which of the variables has a high correlation with our assigned response, which is carbon monoxide in this case. So, and the variable notations are here. And to begin, I will explain to you. So this is the Excel that I was provided. So AT stands for ambient temperature, AP stands for ambient pressure, AH stands for ambient humidity, AFDP, air filter difference pressure, GTEP, gas turbine exhaust pressure, TIT, turbine inlet temperature, TAT, turbine after temperature, CDP, compressor discharge pressure, and TEY, turbine energy yield. So these are the following. Now, to start, go open your MATLAB, and you need to first download the resource pack entitled Deep Learning. It is only through here that you may be able to access the linear regression application. So in order to do that, you just need to go to Get More Apps or Install App and search Deep Learning in the search bar, and you will have your resource package after downloading the necessary requirements. So after downloading, you'll be forwarded. You will have now an additional application procedures in your app bar. So we want linear regression, so we go to Regression Learner. So that's the title of this application we use today. So you'll be forwarded into a window box here. So let me move it so that will not block my camera. So this is the window box shown. So this is the interface, and to start, we need to add the file or the Excel from our chosen data sheet. So this is the file entitled Data Power. This one I showed you earlier. And it has everything from AT, AP, AH until NOx. So if you double check, of course, always double check your variables if all the variables are in your table successfully. And since I already double checked it beforehand before this video started, and so then this is already good to go. Just click import selection, and you'll be forwarded to another variable. So this is where the predictors and the responses you will need to clarify. So according to the problem, our correlation is between CO and the rest of the variables, meaning that the response would need to be carbon monoxide and the rest of the variables as is, however, except NOx. So that means we need to check out NOx from this data set. So meaning, again, based on the based on the given data, I would need to click CO as my response and uncheck NOx since it will not be included in the interpretation of data or as a predictor. Afterwards, we need to cross-validate and 5 false, so just leave it as is, then we can start the session. Alright, after starting the session, we would have this plot. Let me fix my windows a bit. Alright, we will have this plot, and this plot is the response plot. So this plot essentially does not tell us anything yet. It just simply states all of our responses in the Excel and put it in a plot chart or a scatter plot. So what do we need to do is we need to use all regression tree models in performing regression training. So what are the different regression tree models? There are different types of regression tree models. There is a fine tree model, a medium tree model, a coarse tree model. So we need to pick all. So just click here, all trees. That will help us automate everything, since it will automatically use all the tree variations from fine, medium, and coarse. Afterwards, we click train. And as you can see here, the first tree, which is in a basis of a fine tree, is done. With a second medium tree is done, and a coarse tree is also done. So that's quick and easy. Afterwards, this is the response plot. So as you can see here, the data from the Excel, originally from the Excel, is represented by the blue dots. And then after training our algorithm, the device or the algorithm predicted based from the patterns they observed from the Excel. This is what they predict the data. And as you can see here, the predicted data is not exactly 100% similar to the true value, but it is a good estimate at first glance. But however, we need to analyze this further in order to have a greater understanding of what is happening. So this is the response plot, and this is the record number, and we need to change it in terms of different responses. So what happens if we change it to response of CO, where the x-axis is 80 or ambient temperature, as you can see here. So the yellow almost overlaps the blue. However, in the upper part, they are not exactly covering each other. So of course we cannot say 100%, and this is only a good estimate, estimation of what is about to see. So this is for CO and AT only. For ambient pressure and AH, AFDP, GTEP, DIT, DAT, DEY, and CDP. So these are the variables, and we need to, and at first glance it's hard to truly interpret, so we'll need to use the help of the next set of plots. So the plots here is the predicted versus actual plot and the residual plot. So going back, we'll just click here predicted versus actual and residual, and we're already given our data set. Okay, so what are the R-squared values and the RMSE? So to answer this question, the RMSE for the fine tree is 1.3344, for the medium tree is 1.2733, and the coarse tree is 1.3212. Then what's the R-squared value of each tree variation? Well, for the fine tree, it's 0.64. For the medium tree, it's 0.67. And the coarse tree is 0.65. So, between these three tree mediums, which is the best? Well, the rule of thumb is that when an R-squared value is the closest to 1, it means that the variables are highly or strongly correlated to each other. So, between 0.65, 0.64, and 0.67, the best tree for this certain data set is using the medium tree, which yielded the R-squared value that is closer to 1. Alright. Then for the root mean squared value, just simply states that the distance between the line of best fit. But it's we only need to use the R-squared value to have a good interpretation. And so that's the R-squared value of each tree. And again, I already explained earlier, the R-squared value tells us the R-squared value tells us on how strongly correlated the variables are with each other. As when we say strongly correlated, when the R-squared value again is near 1, it signifies that they are strongly correlated. But if it is less than 1 and around the center of 0.5 and 1, like 0.7, it is weakly correlated. They're still correlated, but weakly. And below 0.5, they're not correlated at all. But since this is above 0.5 and almost to 0.7, we can say that this is there is an evidence of correlation, but not that strong. Okay, so that's the response plot. So our next one is, what does the response plot tells us? The response plot tells us is simply compares what our true value, which is the blue, which are data coming from the Excel. The Excel, this one. This is simply plotted in the graph, and the predicted value, which is the predicted values coming from training of our respective regression learner models, and their attempt on trying to simulate as much as possible the true values. So that's just simply the response, but there's no lines, there's no bars, only just dots scattered on the graph that corresponds to whatever axis they are referred to. So this is the AT, and the response is the CO, and continue on, so on and so forth. Now, for the predicted versus actual plot, what does this mean? Well, according to, the predicted versus actual plot essentially tells you on how correlated, how the relationship between the predicted and actual plot. So if our observation is in terms of the XL are the blue, and our perfect prediction based on the regression model is the diagonal line, then the more they are scattered at random and are symmetric to each other, that means that they are highly correlated. But as you can see here, they are scattered very, very close to each other. There is no corresponding nonlinear patterns that I can observe. So what I observe is that they are scattered but not that far. They are kind of symmetrical if we can account for the negligence of the outliers. These are called outliers when they were so far from the line of reference. And then we can say that they are still correlated but very, very weakly, as I said earlier from the response plot. So if you want a better definition, MATLAB states that a perfect regression model has a predicted response equal to the true response. So all the points lie on the diagonal line. The vertical from the line distance to any point is the error of the prediction point. A good model has small errors, and so the prediction is scattered near the line, sorry. So the best model for this predicted versus actual plot is roughly symmetrical around the diagonal line, and if you can see any clear patterns on the plot, it is likely that you can improve your model. So I cannot see any clear patterns, but they are not scattered well enough, so this may be a sign that a further improvement of the plot is still needed. So next is the residual plot. So what does a residual plot mean? Well, in essence, a residual plot is simply finding the distance between the observed data from the best fit line or the line of reference. So let's take into account this is the best fit line of reference, and this data, the vertical distance from the reference line or the best fit line is the residual, and this is the residual, and its distance, the residual is represented from the distance of the dot or the point from the reference line or the null line, which is the zero line. So again, an ideal model for the residual plot is that same thing for the predicted versus actual plot. The data points or the residual points must be symmetrical with a great scattered randomness that has no observable pattern. So a more concrete explanation is that a good model for a residual plot, again, scattered roughly symmetrical around 0. If you can see any clear patterns in residuals, we need to improve our model. So the patterns are the following. Residuals are not symmetrically distributed. Residuals change in size and from left to right in the plot. Outliers occur. So that is, residuals are much larger than the rest of the individuals, and clearly nonlinear patterns. So there are no patterns. So there are no patterns that I can observe. It cannot be forming a cone pattern. That doesn't make any sense. But they are truly situated near in one part, left in just the left part. It's not spread out from left to right, and there are so many outliers, which are values that are very, very far from the 0. So they are still correlated, but very weakly, as I said earlier. So let's try to fix our prediction. And not really fix. Let's try to look at the different perspective. So this is only for the true response. So that's the true response, and the predicted response has an even better spread from left to right. So this one's just almost left in this side, but there's an almost to the center, though still not scattered well, but it's a good start. But there are more outliers now compared to the true response. And the record number, now this is a good residual plot. And now we need to understand this portion. So this is where the axis is now in terms of the different variables that we have regressed. So the residual CO against the different x-axis variables again. So ambient temperature, pressure, so on and so forth. So as you can see here, again, we're going back, the ideal or best residual plot is those that are scattered throughout the line that has little to no outliers and little to no patterns. So at 80 is a good contender for the best correlation to CO, such that it is spread evenly. However, the outliers are the main problem here. For AP, AP is less better, is a bit worse than AP. No, I mean AP is better than AP, since though it is spread evenly, the heights are very, very different. This is more higher than this part, and there are more and more outliers here. The AH, not a good contender, since though it is spread throughout left and right, the outliers are only on the situated. There are outliers, and those outliers are situated on the rightmost side. So there's a specific pattern that we can see here, and it's not good. This part, it's the opposite of AH. So though it is spread, there are different heights from the reference line. So this is a high height, and this is low height, and most of the outliers are on the left side. And same, different heights. This is skinny and this is fat, and the outliers are mostly situated on the left side. And this one, now this is even worse. They're not spread evenly. This part has no data whatsoever. Though the heights are almost the same, the outliers are spread out. Well, that outliers are spread out is a good thing, but there are too many outliers. For T80, similar problems to the earlier ones. This is skinny and this is fat, and the outliers, though many, are scattered randomly with no patterns. This one, almost great, almost. It's a good contender against the 80. However, the outliers again are more situated to the left. The heights are almost the same, though there's a pattern we can see, and patterns cannot be there. No observable patterns must be observed. And this one, also a good contender, such that the outliers are only in the left side, and there are a few outliers. However, the heights here are different. This is high, high, skinny, fat, fat, skinny, fat, skinny, skinny, fat. So I would so in my analysis, AT, EY, and CDP. So if I have to pick, I would pick that the highly correlated variable with response to carbon monoxide is AT, or ambient temperature, because again, going back, it is a good spread. The heights are almost the same, though the tips, they're just different, but in the center they're almost the same. And the outliers, though there are many outliers, they are still spread out across, and they are kind of symmetric, almost symmetric as well. So I chose that the best the best variable that is in correlation with carbon monoxide is ambient temperature. And essentially that is it for this exercise. So again, my name is Ron. This is exercise 6, and thank you all for listening. Thank you, and